This session is for OCR FP2. The topic is polar graphs, and we're going to look at question 4 from June 2011. So if we have a read through the question first of all, so it tells us that we've got a curve C with Cartesian equation x cubed plus y cubed equals axy, and we're told that x and y are greater than or equal to 0 and a is greater than nothing. And first of all, we're asked to express the polar equation of C in the form r equals f of theta and state the limits between which theta lies. We're then told that the line theta equals alpha is a line of symmetry of C. And in part 2 it says find and simplify an expression for f of a half pi minus theta and hence explain why alpha equals a quarter pi. And part 3 says find the value of r when theta equals a quarter pi. And in part 4 we're asked to sketch the curve. So a total of 9 marks for this question. So let's have a look first of all at part 1, where we're asked to express the polar equation of C in the form r equals f of theta. So this is the information that we need here, really, from the theory of what we're going to do in terms of changing from Cartesian to polar. So we have a point with coordinates r theta, where r is the distance from the origin and theta is the angle that it makes with the positive x-axis. So we know that x equals r cos theta, y is equal to r sin theta, and we would also know, of course, that x squared plus y squared equals r squared. But I don't think we'll need that in this case. So what we're going to do is we're going to replace, in terms of x cubed plus y cubed equals axy, then all we have to do is replace x by r cos theta and y by r sin theta all the way through, and we're going to have then an r squared cos theta sin theta on the right. And we could take out a factor of r cubed on the left as well, so we have a cos cubed theta plus a sin cubed theta, and you'll see then that we can actually divide through by r squared. So we'll divide through by r squared to get r upon cos cubed theta plus sin cubed theta equals a cos theta sin theta. And the last thing we need to do is write it in the correct form, so we can write it as r equals a cos theta sin theta all over cos cubed theta plus sin cubed theta. So we have expressed it now in the form r as a function of f. The other thing we're asked to do is to state the limits. So just be aware that it's important information we're given here is that x and y are both greater than or equal to 0. So the limits are that theta must lie between 0 and pi over 2. So there were 3 marks for that question, and if we just have a quick look at how you get the marks there. So there was 1 mark for getting to this sort of stage, here an accuracy mark. There was a method mark for substituting in here for x and y, x equals r cos theta, y equals r sin theta, and then there was an A mark, an accuracy mark there for giving the limits. So just 3 marks for that part. So if we move on to part 2, what we're asked to do in part 2 is to find and simplify an expression for f of a half pi minus theta. So I've got the formula that we have worked out in part 1 written there. So all I'm going to do now is to substitute everywhere we have a theta. I'm going to substitute for a half pi minus theta. So I'm going to have a cos a half pi minus theta sine a half pi minus theta. I'm just working all the way through. So I'll have cos cubed a half pi minus theta plus sine cubed. A half pi minus theta. So we just need to show that clearly. And then the important thing to remember, of course, is that if you find the cos of a half pi minus theta, then that is the same as the sine of theta. So if you get muddled about things like that, sometimes it's a good idea to think about degrees and remember that the sine of 30 is the same as the cosine of 60 and so forth. So here we just need to show that in fact we can replace a half pi minus theta, the cosine of that will be the sine of theta, the sine of a half pi minus theta is the cos of theta, and similarly down here. So that will become sine cubed theta, cos cubed theta plus cos cubed theta, which if you look at it is of course exactly the same as f of theta, because the order in which we multiply in the numerator doesn't matter and the order in which we add in the denominator doesn't matter. So what we've really found is that f of theta is equal to f of a half pi minus theta. Now the condition, what we should know is that the condition for a line of symmetry is that f of 2 alpha minus theta equals f of theta. Then that means that theta equals alpha is a line of symmetry. And the fact here that we've shown that f of theta is equal to f of a half pi minus theta, that tells us that in our case, if you like, our 2 alpha here is a half pi, and so alpha is equal to a quarter pi. So 3 marks for that question. There was a method mark here, if I just put it in red, there was a method mark here for substituting in everywhere with a half pi minus theta. There was an A mark, an accuracy mark here, and then there was an A mark for this sort of statement, just to show that that meant, that confirmed that alpha was a quarter pi. So if we move on now to part 3. So in part 3, what are we asked to do in part 3? We're asked to find the value of r when theta equals a quarter pi. So just remind ourselves that of course the cos of a quarter pi equals sine of a quarter pi equals 1 over root 2, or root 2 over 2, whichever you prefer really. So all we're going to do is substitute that in. So we have a times 1 over root 2 times 1 over root 2 over, well, cos cubed is going to be 1 over root 2 cubed, and then you'll have another 1 over root 2 cubed there, won't we? So you just need to go through and just check that you can simplify that. There's only 1 mark for this question. So just go through and check that you can simplify that and get a half of root 2a. So just simplifying your thirds and your fractions and things, we should be able to get that. So just literally 1 mark for getting that. And then part 4, and in part 4 we're asked to sketch the curve. So 2 marks to sketch the curve. So the important bits about this, first of all, if we gather up the information that we have throughout the question, we know that the range is between 0 and theta is between 0 and pi over 2. So you'll see I've just drawn the first quadrant here. We also know from what we did in part 2 that theta equals pi over 4 is a line of symmetry. So we can put that in. So I've drawn in the line pi, y equals x, the line pi over 4. We also know that if theta equals 0, or in fact theta equals pi over 2, then in either of those cases our numerator is going to be equal to 0. So that would tell us that r is equal to 0. So that means that when theta equals 0, which is your horizontal line here, and theta equals pi over 2, so this is pi over 2, and this is naught, and this is pi over 4, then we know now that the line here, the horizontal line and these vertical lines r equals naught are going to be tangents. So in fact our curve is symmetrical, so it'll go out and it will look something like that. That's going to be more or less the shape. I shouldn't really be using a dotted line, but it is going to look something like that. That's what we're looking for. And if I just give you a nice sort of accurate diagram, that's what we've got. Now there were 2 marks for that question, and basically what happened is that you got 1 mark here for this bit, a statement mark, a B mark they refer to it as, just for these 2 conditions, and then you got another mark here for showing that these lines were tangents. So 9 marks in total, as I say, for the question. So don't forget that if you want to watch more videos, then just go to the Further Maths Support Programme webpage and you'll be able to follow the link.